Alright, today we're going to have a look at integration using partial fraction decomposition. Now, questions involving partial fractions require us to take a rational function and convert it into two or more single fractions, the partial fractions, that we can easily integrate using standard integrals. And often we're going to integrate it using ln, you'll see that show up a lot. Using this method, we, first of all, in method 1 by equating coefficients. So we're going to work with our end goal and place letters, usually A or B or C or D, on the numerators, and then cross out and multiply these and equate coefficients. So our goal with this question is to say that this is the integral of something x plus 1, let's say A, plus something B on x minus 2. Now, when our coefficients on the denominator are linear, which means they're straight lines, the graphs of straight lines, we just want constants up here. But if these were quadratics, we need to say ax plus b or something on the top. So we're going to cross multiply these. So a, x minus 2, plus b, x plus 1. And that's equal to ax minus 2a plus bx plus b, which is equal to x, a plus b, plus b minus 2a. So by equating coefficients, a plus b has to equal 2. And b minus 2a has to equal minus 7. So if we solve those simultaneous equations, we're going to get a is equal to 3 and b is equal to minus 1. So this is equal to the integral of 3 on x plus 1 minus 1 on x minus 2 dx, which is simple. This is just 3 ln of x plus 1 minus ln of x minus 2 plus c. Okay, that's what we do in partial fractions decomposition. Let's have a look at a second example. So 9x minus 2 on 2x minus 1x minus 3. So we're going to just do our partial fraction decomposition. So 2x minus 1 plus x minus 3. We're going to call this a and this b. Again, we're going to learn a method later that's going to make you be able to do this in 2 seconds, but we need to develop this ability to equate coefficients, especially when the denominator is quadratic. So this is going to be ax minus 3a plus bx, plus 2bx minus 2b. And that's going to be congruent to 9x minus 2. Now let's equate coefficients. X, we're going to have a plus 2b, and then minus 3a minus 2b. So that means a plus 2b has to equal 9, and we might say 3a plus 2b has to equal positive 2 by getting rid of all of those negatives there. So from this we can see that a is 9 minus 2b, which means that 3 lots of 9 minus 2b plus 2b equals 2. So how many b's do we have? We've got 2b minus 6b, which is minus 4b. And then 3 times 9 is 20, no it's not, 3 times 9 is 27. Let's subtract that to the other side, so 2 minus 27. Oh, that's not going to be pretty. Let me just check if that's right. Generally, if it's a fraction, sometimes something's gone wrong. But let's just double check. I like to double check if I get a fraction. So ax minus 3a plus 2b minus 2bx minus, I have made a mistake. That's going to be minus 2b there, minus 1b, which that's 1b, and that's 1b. And that's going to be 1b there. Right, so instead of having, so we're going to have, I might just do this the long way, 27 minus 6b plus b equals 2, kills me to do that. Yeah, that's going to be much better, which means b is equal to 5. which means a is going to equal 9 minus 10, which is minus 1. It's a good strategy there. Just check that you've done it right. You can see I made a mistake there, and I quickly was able to see where I went wrong, and I fixed it. So therefore, this is equal to the integral. A is minus 1, so minus 1 over 2x minus 1, plus 5 on x minus 3, which is equal to minus ln, or not quite, minus, we want to have 2 on the top, so we're going to put a 2 here and a half here, so this is minus a half ln of 2x minus 1 plus 5 ln of x minus 3 plus c. Okay. So example number 3 is a bit different because now we've got quadratic things on the bottom. So the problem with this question is that we're not just going to split it up into basic things. So the numerators of each of these must be ax plus b, because we need to somehow get x squareds on the top and individual x's on the top. So we need to write this as x squared plus 1 plus x squared plus 2, ax plus b plus cx plus d. The reason we need to do that is because if we didn't do that, if we just say had b and d on the top, well, when we multiplied these up here, we're not going to have any x terms. So we need to do this, and it's going to take us a while, unfortunately. But we need to go, okay, ax plus b times x squared plus 2 plus x squared plus 1 times cx plus d. And that's going to be congruent to 3x squared minus 2x plus 1. Now if we expand this, ax cubed plus 2ax plus bx squared plus 2b plus x, cx cubed plus dx squared plus cx plus d, and that's congruent to the same thing. So this is x cubed a plus c, let's start cancelling these out, plus x squared b plus d, what have we got? B plus d plus x 2a plus c plus 2b plus d. Now equating coefficients, a plus c has to equal 0 because there's no x cubed term. B plus d has to equal 3, that's my x squared term. 2a plus c has to equal minus 2. And 2b plus d equals 1. Now if you have a go at solving those 3 equations in 3 unknowns, or 3 equations, 4 unknowns in 4 equations, you're going to get a equals 2, b equals 5, what else are you going to get? C equals minus 2, I think. No, you're not. Let me just quickly check that. I'm just checking my solutions from before. You're going to get b equals minus 2, a equals minus 2 as well, d equals 5, and c equals 2. So I'm not going to show you how to do that. That is quite easy to do, and I want to save time making this video. So this is going to be the integral of minus 2x minus 2 over, what's that going to be? X squared plus 1 we had first, plus, what's this going to be? 2x plus 5 over x squared plus 1. Now, is this definite or indefinite? Definite. Indefinite, which is nice. So if we integrate, I might take out this minus to here and make that a plus and put another integral there. If we differentiate him, we get that. That's nice. Differentiate that, we get that. So this is minus ln of x squared plus 1 plus ln of, that should be plus 2 on the bottom there. Plus c, and we're done with that one. Okay, this example here, we are going to realise that here we've got a repeating denominator. What I mean by that is whenever you've got a quadratic, something that's squared, a whole function that's squared, like x squared or x minus 1 squared, not x squared plus 1 individually, but if the whole thing is squared, we have to repeat the denominators like is shown below. Now, I'm pretty sure according to the syllabus you don't need to know how to repeat the denominators. It's quite straightforward, but they have to give you the clue in an exam. So to do this, we're going to look, okay, our goal is to have a denominator of x squared x minus 1. So to make the first denominator x squared x minus 1, we have to multiply it by x minus 1. The second one, we only need to multiply it by x minus 1. And the third one, we only have to multiply it by x squared, because that would get us x squared x minus 1. So if we expand all that, we're going to have ax squared minus ax plus bx minus b plus cx squared. And if we have a go at equating coefficients, let's combine them. So it's going to be x squared a plus c. That's telling us a equals minus c, but we'll get to that in a second. X times by b minus a. What have I done? That minus b. Now that is telling me minus b has to be congruent to minus 3, which means b is equal to 3. A plus c has to be 0, because there's no squared x squared term here. And b minus a has to be 2. Now if a is minus c, well, we also know that b is 3. So b minus a equals 2. But b is 3, sorry. So that means a is 1. And that means c is minus 1. So this is equal to the integral of 1 over x plus 3 on x squared minus 1 on x minus 1, which is just ln of x minus 3 on x minus ln of x minus 1 plus c. Okay, what might we do here? Elimination by substitution. Now, we've just seen this exact same integral, and I'm going to lead you to one of the previous steps here. So I'm going to go to this step right here. And I'm going to talk about what I mean by elimination by substitution. So the second work method involves, it's quicker than the first method, and it works when the original integrand has a single linear factor, but for more involved questions, the first example, works for single linear factors, but for more involved questions, we've got to equate lots of coefficient, and it can be quite tricky. So we can do this by not equating our coefficients and cross-multiplying but not simplifying, and then substituting in a value of x. So we know that 2x minus 3 is congruent to that. So if we substitute it in x equals 0, we're going to have minus 3 equals 0 plus 0 minus b, which means b equals 3. If we let x equal 1, we're going to have 2 times 1 minus 3, which is minus 1, equals a plus c plus b minus a, and b is 3, so minus 3. Now the a's will cancel and we get c plus b. Oh, actually, and as well, b we know is already 3, so that 3 and that 3 will go, the a and the a will go, and we get c is equal to minus 1. Now if we, what have we got? We've now got the expression, well, we know a plus c has to equal 0, so let's just equate one coefficient because there's no x squared term. So a plus c, and since c equals minus 1, a minus c equals 0. Sorry, what am I doing there? C equals minus 1, so a minus 1 equals 0, which means a equals 1. So those are the three numbers we came up with before, and then we can just do the same integral as before. Okay, the next method, I thought I came up with this on my own, but I was looking in some textbooks and other people had discovered it, so unfortunately I didn't come up with this on my own, but let's just pretend I did, because I discovered this, I'm not sure if my teacher showed me, I forget, but I'm pretty sure I discovered this just through working, and it's through the cover-up method. So the cover-up method will only work when our denominators are the product of two linear functions. And we do it like this. We want to go that this is equal to something on x plus 1, something on x minus 2. And to get the x plus 1 term, we're going to figure out what do I have to do to x plus 1 to make it 0. And that means x equals minus 1. So I'm going to cover up this and substituting minus 1 into the rest. So 2 times minus 1 minus 7 over minus 1 minus 2. So I'm substituting in minus 1. So 2 times minus 1 minus 7 divided by minus 1 minus 2. And if you do that, you get 1 over 3. No, you get 3 maybe? Let's just check. So 2, I'll just do it on my calculator, 2 times minus 1 minus 7 over minus 1 minus 2, yeah, you get 3. So we're substituting in minus 1 into here. So if you do that, you get 3. Now, what we're going to do next is we're going to figure out what do I have to do to this one to make it 0, and it's make this 2. So we're going to forget about this and substitute in 2 into the rest of the equation. So 2 times 2 minus 7 on 2 plus 1, you get minus 1. So this is minus 1 here. So this is 3 ln of x plus 1 minus ln of x minus 2 plus c. Now this question here, is this the same as before? Let's check. 2x, yes it is. We can use this magic method only on the linear factors here. So we can say this is something x squared, something x minus 1, and we're going to realise what do I have to do to this to make it 0? I have to make it 1. So I'm going to substitute in 1 into everything else. So 2 times 1 minus 3 over 1 squared, which is minus 1. So that's minus 1 there, and of course we still need to repeat that there, so 1 over something over x plus that. And we can just have a go at equating some coefficients to finish this up here. So we call this, what do we want to call this? A and this B. So we've already figured out C. So let's go, okay, this is going to be A. Our goal is to have a denominator of x squared, x minus 1. So it's going to be A times by, we have to times this by x minus 1. And that will get us x squared, x minus 1. Plus B, we just need to times it by x minus 1. And C, we need to times it by x squared, so minus x squared, because c is minus 1. So ax squared minus ax plus bx minus b minus x squared, and that's of course congruent to 2x minus 3. So we've got x squared a minus 1 plus x b minus a, and then we've got minus b. So, and that's congruent to 2x minus 3. Nice and easy, because that means this is 0 because there's no x squared term, so a equals 1, b of course equals 3, and we don't have a c term, so we're done. And then we're just going to apply that and integrate the same question we've already done twice. Alright, thanks for watching.